In this video, we're going to start to look at how we can create an AC equivalent circuit to do our small signal analysis. And so what we're going to do is we're going to deactivate the DC sources in order to create a circuit that has only AC signals. And so let's keep in mind that this is only for doing analysis. So only for analysis. So we can't go to the physical circuit and remove our DC sources, because again, then we won't be biased at the appropriate spot, we won't be at the cue point that we designed for, and our amplification won't work. So again, it's only on paper for our analysis that we're removing or deactivating these DC sources. In this case, we're going to consider the circuit from the previous video. So we just have two DC voltage sources, VCC and VBB. Now, if we want to deactivate a voltage source, that means we want it to have zero voltage. If we want zero voltage, we just short it. So if we short our VBB, so I think that's pretty easy to see, that will just go away and we'll have just a straight line connecting that. Now for our VCC, it's going to be a little different than what we've seen before, because again, remember, we could draw this a little bit differently, and we could draw this as a voltage source VCC between that point and ground. So now it's a little bit easier to see that we would just replace that with a short circuit such that the top of our RC is at this new ground. And so the way I've represented that over here is I've just taken that line from the top of our RC over to where we've already defined our ground. And so what we would say is we would say that the top of our RC, or so let's say top of RC, so that node up there, is going to be at signal ground. And so this idea of signal ground is something we're going to be talking about a lot and sort of using a fair amount from here on out. So it's important that you understand the difference between a signal ground, which is where we've sort of, again, just in our analysis, deactivated these DC sources, which is not necessarily a physical connection to ground. So we're not necessarily connected to, from this point, to some grounding rod, for instance, but rather for the purposes of our AC analysis, we can say that that points at ground. So again, sort of in that same vein, while we're doing this AC analysis, we're going to implicitly assume that we're still biased at the cue point and we're in the forward active mode. So we implicitly assume that our BJT is in the forward active mode while doing AC analysis. And so again, that's pretty much just the same, writing out the same thing that I was saying earlier. So our AC, or we can also call it our small signal analysis. Okay, so ultimately then we get some AC equivalent circuit that looks like this over here on the right. Well, so we want to actually take that a step further. And so how can we take that a step further? Well, we can make an AC equivalent model of the transistor itself. So let's come down here and say we want to take it a step further with an AC model for our BJT. And so it turns out that there are several different models that we can use for this. One that we're going to focus on is called the hybrid pi model. And so we're going to talk about at least one other one just in passing, but for the most part, the hybrid pi model is the one that we're going to use. And we're going to come back in the next video and we're going to talk about that in more detail. But the basic idea is we're going to take that BJT transistor and we're going to treat it like a two-port network. And so what that looks like then is we can redraw that BJT as something that looks like this. So notice I've labeled our base, emitter, and collector terminals. And by definition, with a two-port network, we have an input port with two terminals. And so over here on the left, we can say our base emitter port is our input. So we have some input current, which is our base current, some input voltage, which is VBE. And then over here on the right, we have our output port, which is our collector emitter junction, or not junction, but our collector emitter terminals. And so we have some output current IC as well as the output voltage VCE. And so in the next video, we're going to come back and we're going to expand on this hybrid pi model. And so the idea is that once we've developed this AC model for our BJT, we're going to take that and we're going to plug it in here. And once we do that, we'll have an AC, sort of AC equivalent circuit that we can analyze, and we can figure out what our small signal gain is, various other things that we'll get into later. But that's going to be a very useful first step in doing our AC analysis.